Let us evaluate this integral. It's an integral along a curve. As you can see, integral sign on the C here. It's taking place along a curve, which could very well be a straight line. We still call it a curve. It's the integral of x squared plus y dx plus x squared plus y, x plus y squared dy. So the x squared plus y is a component. It is the horizontal component. It's taking place along x, right? So you have each portion you divide the curve into. There is this portion in the x direction. So it's x squared plus y in the direction x, changing x dx, alright? And then there is that portion, x plus y squared, in the direction y. Which is dy. Okay? Alright. So that would be the horizontal and vertical component of the chord that you divide the curve into. I'm imagining that this is the curve. But if it is a straight line, then you can still divide it up into parts. Alright? Alright, so you divide it up into those horizontal and vertical components from a point A located at 0, 2 to point B located at 3, 5. So if you imagine your graph here, 0, 1, 2, 3, 4, 5, 6, x-axis, the y-axis, 1, 2, you have 3, 4, 5, 6, and so on and so forth. You're looking at 0, 2, which would be right here, to 3, 5. 3, 5 would be here. Alright? Above 3 and beside 5. Along the curve x plus 2. So it is a straight line. Alright? It's a straight line. So you're looking at the graph from here. Alright. Now, this is the integral that you're dealing with. Now when you look at it, you have x and y's, x component and y component. What you need to do is this. You're going to use the formula for the curve. And as you know, when you do an integration, you normally integrate a function of x dx. Right? So what you do is change y to x. This will give you f of x, right? Instead of f of x and y. Alright. You also change dy to dx. How do you do that? Well, let us see. The curve is y is equal to x plus 2. That is the curve. So you substitute that into the curve. So what you have is the integral. Well, you don't have to write c here anymore because you know where you start and where you end. Right? So you integrate from x equal 0 to x equal 3. You find the integral from x equal 0 to x equal 3 of x squared plus y, but y is x plus 2, and you only want x's, so it's plus x plus 2 dx. Alright, plus, let's see, x plus y squared, but the thing is you don't want any y's, you want only x. So y is x plus 2, so y squared is x plus 2 squared dy. Alright, so we still have a problem here. We have a dy. We need dx throughout. Now, since y is equal to x plus 2, when you differentiate this with respect to x, dy by dx is equal to, well, it would be 1. So therefore, dy is equal to 1 times dx. dy is equal to dx. We don't have to put the 1 there. So dy is equal to dx. So we can just rewrite this as dx. Alright? So the dy, it is dx. Same thing as dx. So just write dx here. You see that? Okay, so what we have, let's simplify. What we have here is the integral from 0 to 3 of x squared plus x plus 2 dx. See that? Plus, and then what we have here, x plus y squared. This is going to be x plus, when you multiply with x plus 2, x plus 2, x plus 2, let's just do this one side as a rough work. So it's x squared plus 2x plus 2x, that's plus 4x plus 2 2's 4 dx. But x plus 4x is 5x. So we could rewrite this as plus 5x plus 4. Okay. And the integral applies to all of it. So let me put a square bracket around it. Alright. So here now, we have the integral from 0 to 3 of, now let's open the brackets. Oh, yeah, we have 2 dx's added here. So we're going to open the bracket after that. It's going to be x squared plus x plus 2, right, plus x squared plus 5x plus 4 dx. Nice. So we have the integral from 0 to 3 of, So x squared plus x squared, that's 2x squared plus 5x plus 5, x plus 5x is 6x plus 4, 5, 6 plus 6 dx. We could very well factor out the 2. So if we factor out the 2 and put it outside, we're going to have 2 times 1x squared. This will be 3x plus 3 if we factorize. Okay, we didn't really need to factorize it, but it's easier to deal with smaller numbers. So we have 2 times what now? Let's integrate x cubed plus 3x squared over 2 plus 3x from 0 to 3. So we have 2 times what now? Well, x cubed is 3 cubed plus 3 times 3 squared over 2 plus 3 times 3 minus, it's 2 times everything. Well, we would have 0 cubed plus 3 by 0 squared over 2 plus 3 by 0. So all of that would amount to 0. That part would come to 0. So we have 2 times 3 3 is 9, 9 3 is 27 plus 3 3 is 9. This would be 27 over 2 plus 3 3 is 9. Okay. Equals. Alright, so let me just use my calculator. It's going to be well, could just use the calculator on screen here. Use the calculator. I have a calculator here. It says 27 plus 27 over 2 equals that plus 9 equal, and multiply that by 2 equals. Alright, and that gives us 51.5, right? So ensure that you understand what's going on here. Alright, oh, let me do that calculation again. Why it looks like that? 27 this, I need the other calculator, and I didn't install the other calculator, but it's more accurate. 27 or not that it's more accurate, but the programming of it make it more convenient to use. 27 over 2 is 13.5 plus 27 plus 9 is that, oh, times 2, right? I didn't multiply it by 2, it's 99. It's 99. Yeah, that's look more like it, what I would be expecting. Because if you have 27 and 9, that's 37, 36 and some more, and you multiply by 2. Looking at something approaching 100. Alright, good. So that's what we have there. Alright. So, do a quick review. We have the integral of function of x and y dx plus a function of x and y dy. What you need to do is find the integral of a function of x alone dx. So use the curve given and you substitute and change y to x, and you differentiate that the curve, the function of the curve, to find out what dy is. Alright, so it would be something changed to dx. Then you make your substitution, integrate between the boundaries 0 to 3, and you work it out and you get your answer. Alright, so I'll see you in the next video.